Hello everyone and welcome to this week's plugin tutorial. In this one, I'm going to be showing you how to use image sampling inside of your After Effects and or Premiere plugins. We're going to be using the basic built-in example plugin called Shifter, which will allow us to essentially have two images displayed. We can change the opacity to see the before and after, but we're able to use this offset point value to then shift our image that many pixels up right, up left, down left, etc., or wherever we put this. So today we're going to be taking a look at plugins built-in sampling methods, how we can sample different pixels, and basically what we're able to do with these methods. And of course, if you're not familiar with sampling, that is simply looking at a certain pixel location and getting the RGB values. And with this, you can do a ton of things like change your image, shift the channels, and create all sorts of effects. Before we get started, I do want to remind you down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel. And down in the description, you can follow us on GitHub for coding updates, as well as Instagram for other live updates. If you're not already a member of our Discord server, make sure you come and join to get help with scripting, extensions, plugins, submit tutorial ideas, and much more. And if you'd like to help support us on YouTube, you can do so in the description by becoming a member, supporter, premium supporter, or VIP, and that comes with cool perks. And also make sure you check out the links down below to AE Scripts, Gumroad, and Adobe Exchange to check out some of the other cool stuff I make. Alright, so the first step in anything we learn in plugins usually starts within the SDK guide. So if we take a look at the PF sampling suite functions, which is what you can search to find this, if you type in sampling or anything else, it doesn't quite come up. So type in PF_sampling suite and it should come up. We have basically a nearest neighbor type sampling, a sub-pixel type sampling, as well as an area sample. Now, nearest neighbor is basically what people use to scale up small kind of images into larger images without losing too much quality. It's good for kind of size interpolation type of scaling or sampling. Sub-pixel sampling, as it basically implies, allows you to sample within subpixels and get a little bit more detailed. And then finally, of course, area sampling allows you to sample sort of boxed areas within your image itself, and that will return basically averaged out values of the entire section you're analyzing. You can actually define how specifically you want your search to be in the radius of your search object, basically. And for these other ones, they're more searching individual pixels and sampling that. And like I said, this is for 3 different bits per channel. We have 8 bits per channel sampling, 16 bits per channel sampling, and of course float or 32 bits per channel sampling. And all of these are basically going to work the same way. We need to provide an effect reference, which is usually from our in data inside of whether it be a render function, or we can also pass it down into an iterate function, which is quite normal. Then we need to provide an X and a Y in fixed format. This is going to tell it where in the incoming effect reference image to look. Most of these sampling functions work exactly the same and have the same arguments. You start with a progress pointer to your effect reference, usually referencing your in data. You can do this in the render side of things, but you really want to kind of pass it down into your iterate function so you have access for all of your X and Y pixels, which are the next 2 arguments. Which X and Y pixel are you going to be looking at on your image to sample? So you obviously can have control over this and be looking at one pixel, but sample a pixel over here. And that can be used to do a lot of mathematical calculations. And then something that's very important is the PF sample PB. This is basically the world or the effect world that you're going to be sampling from. You can sample your layer you've applied the effect to, but you can also use other layers using layer dropdowns and bring them in here. So if you wanted to use, say, like a matte layer and sample using that, you could put it in here. And then lastly, we have the pointer to the destination pixel where we're going to store the sampled data. This is obviously coming in as an empty pixel, and then we're going to fill it in with whatever the sampling provides us with. Now that we've looked at how it generally works, we can look at some actual code, and the project you want to open up is called Shifter. Under examples, effects, and Shifter, go ahead and load that up, and this is going to show us everything we need to know about sampling, showing us it in an actual method here. So this is actually, I believe, showing us 8, 16, and float suites. We go inside of our smart render function here, and we can see we have all three of the different bit rates for After Effects called here. We have a shift image 8, a shift image 16, and a shift image float, which is perfect. We have an iterate float and an iterate for each of those bit rates. And let's go ahead and dive into each one of those and see exactly how they work. We can go to shift image float, for example, and this should tell us kind of how it works. So first off, we have our shift info. This is the data structure we're using in this case. So if I go into my shifter.h, we should have our shift info defined here. We have an X offset, a Y offset, a blend value, a reference progress pointer, our sample PB variable, which is important in order to have custom or any kind of effect world or layer sampled, an in data, and a no operation bool. Now all these are required, and honestly all we really need is an offset as well as the input world that's going to be sampled. So let's go ahead and take a look at how exactly we're going to calculate that. If we want to just sample the original pixels we're looking at, all we would do is just provide it with XL and YL. In this case, we are doing an offset so that we can kind of have a cool effect. But let's go ahead and first illustrate it in this float function if we just sample the X and Y. So one thing to note here is that the X and Y values required for at least the float version of this sampling function is a fixed type variable. So if you're providing it with a float or an integer, make sure you use these useful fixed to int, int to fixed, fixed to int or round, fixed to int float, or float to fix functions or methods to get the right values beforehand. You can also cast them directly in the call, but you can see here. Let's quickly take a look. We have our data structure called SIP here, our shift info pointer, which is what it stands for. And we have an in data effect reference referring to that structure, as well as a sample PB referring to that structure. But they're not defined anywhere in our image float. So let's go back up and find where they're defined. You can see here we have info ref, info samp PB source, info in data. So right before we go into our switch statement to check our bit depth, we're actually defining these variables here. We have our data structure, which is our shift info. It's called info p, and we're going to set the values. The reference value is going to be our effect reference from our in data. I should note that with these methods and these sampling functions, you actually don't always have to provide an effect ref. You can actually provide null a lot of times to here, but it is just good practice to bring in an actual effect reference just in case. So we define that here using our input world. Again, if you wanted to, so we set up our effect ref using our in data, which is very normal for basically everything. We use it also for things like the iterate suites and stuff. And then after that, very important, we set up our samp underscore pb.source. You may have noticed in the actual code, in the function we use samp pb, but to actually set it to a certain effect world or layer, you need to set the samp pb.source to that effect world. The source of a samp pb is indeed an effect world. You can see we have an X radius, a Y radius, an area, a source, and a few other behaviors we can set for any samp pb struct. Hopefully that's not too advanced, but basically with this samp pb, if we are going to end up performing, say, an area sample, we could say info p, take our sample object basically, and then we have our other properties in here. If we wanted to increase our X radius, we could make it 10. And if we wanted to have a Y radius for an area sample, we could have it be 10 as well. So instead of analyzing just the individual pixels themselves, we could have an area, and this is where you'd want to change it inside of this sample PB property. Just to let you know, all the other methods, the subpixel and the nearest neighbor sampling by default will have an X and a Y radius of 0. So if you ever want to explicitly set it to what it should be, you can just set them to 0. But yeah, like I said, you want to set your sample PB source to whatever your input world is. It doesn't, of course, have to be your input world. If you had a vector world or something, which you had as a separate layer with a dropdown, you could put that in here as well. This is essentially very important because it's what's going to be get sampled. Not by default will your layer that your effect is applied to be sampled, whatever you're using as this here, this sample PB source, is going to be your input effect world for your matte. And then of course we have also an in-data variable, which we're setting to a pointer to our actual in-data. So back inside of shift image float, we see here we have as well our X and Y. We have our in-data effect reference, our sample PB, which is going to reference our input layer as a source, and then we have outp, which in this case is referring to a pixel float. But if we wanted to, we could define our own pixel and put it in there. You can make a PF pixel float or PF pixel 32. We could just call this sample pixel. And if we wanted to, we could use a pointer to that pixel to store it into that pixel. After that, we can manipulate that pixel and then set it to the output. So let's go ahead and do that. First, I'm going to set this back to outp. And I want to run this to make sure it works first. I'm going to use 32 bits per channel. And we'll need to fix whatever error is here. I think we have very strict debugging on, so we'll need to say treat warnings as errors, no, and then restart it. Then we'll go ahead and make sure we're in 32 bits per channel. We will load up a sample clip into a composition, and we'll go to Effect, Sample Plugins, Shifter. Now, we shouldn't see anything here. The only thing we should see is a one-to-one image with our original. We can offset this as much as we want, but because we've removed the XL and YL here into just be our original values, it's just going to display the original image, which is fine. The next thing I wanted to illustrate is how we can then use this sample pixel we created. We'll need to, again, give it the pointer to there. How we can then use this and manipulate its values afterward. So I can say sample pixel.red divided by 2. And maybe we want to do that for each of the channels. We want to divide each of the channels divided by 2, or we could even divide some by 3 or something else. We can make the sample pixel alpha the same as the input pixel alpha. And then in order to make sure the outgoing pixel is the same as this, we'll need to set each of the values to each other. You might think that you could just say outp is equal to sample pixel. I believe we have to do it individually one by one. Maybe we can do that. But I think it's best to do it one by one, just to better illustrate what's actually going on for the newer users. So what we're going to do is set our output pixels red channel to the input, or to the sample pixels red channel. And we're going to do the same for each of those. Output green, sample pixel green. Output blue, sample pixel blue. Output alpha, we can put as the input alpha actually, and just save on a line up here. And I'm also going to set a breakpoint right here when I first want to change my sample pixel value. This will allow us to actually see what the sample pixel value is. And what it should be giving us is the actual float pixel value for whatever the current pixel is. In this case, an R value between 0 and 1, or it could be less or more because it is a float pixel. So once again, I'm going to create a comp here in 32 bits per channel, apply my shifter, and now let's go ahead and see here. Our breakpoint moved down here. Interesting. Oh, I didn't set this equal to anything. This needs to be sample pixel divided by equals. So that way we divide it by this number and then set it equal to that, rather than just doing an operation without setting it to anything. All right, we apply shifter. And we're at our breakpoint here. Let's see what our sample pixel says. Our alpha is 1.0, so fully opaque. Red is at 0.422, green is at 0.4, and blue is at 0.294. That's our actual sampled pixel value. And now if we inch forward here, you can see we're going to take our green channel and divide it by 3 and set it equal to that. Blue divided by 2, green divided by 5. And then we're going to set our output to our sample pixel. So now if I continue and remove all my breakpoints, and we go look at what this actually creates, it should be some kind of interesting tint effect, because essentially we're just applying math to our various color channels. They're all going to be pretty dark and muted because we're just dividing their original values. But this shows how we can take our sampled pixels and then change the values using another pixel variable and outputting them as something different. Of course, one other cool thing we'll want to do is move our sampling around so that we can pick different pixels. There's a lot of different possibilities you can do with this. You can sample random pixels and create sort of a random mosaic. You can sample only horizontal pixels and kind of create these stretched images, only sample vertical pixels and create kind of slit scanning effects. It's really up to you how creative you want to get with this. But if you remember, here we were previously adding an offset to our XL and YL values. One thing we could try is to create a random x, say int rand x is equal to floor, and we're going to say this is not JavaScript, so I'm not super used to how to do random stuff. I believe it's rand modulus or modulo a number, and that should give me between what, 0 and 100, so maybe 1920. And then we can say sample a random x value. So hopefully if this works, actually let's remove our sample change there. What this should do is sample a random x horizontal value for every pixel that it samples. That means essentially it's going to scramble each row. Each column should contain the same original pixels, but they'll just be shifted, I believe, on the x-axis. Apply shifter. And as you can see, it appears to have done something. This might be hard to tell at first, but essentially what we've done by scattering everything on the horizontal axis is basically created this sort of peppery, salty, salt and peppery kind of grain effect, if you're familiar with that, where it just kind of creates this interesting noise, but you can still see the original image. You'll also notice that because we're sampling so many pixels, each frame takes about 2 to 3 seconds in this 1080p example to load. One thing to note is sampling can be a bit slow on the CPU, so try and use it sparingly, or try and cram all of your sampling into the same function if you can. So as you can see, this is an interesting effect, and we can apply random values to our X and Y sampling. We can apply an offset based on, say, this slider here. We can add an offset, say, based on this 2D option here. There's really all kinds of possibilities we can do when sampling. And it doesn't seem like we're doing like sampling in this particular case, but we really are just picking random pixels and redistributing them. We can do the same thing on the y-axis by creating a random y and just randomizing it between 1080. Of course, you can actually take the actual width and height if you put it in your struct and then bring it down here. So I'm going to go ahead and do that. And let's go ahead and preview this. Or what we could even do, instead of setting this explicitly to that, we could say take our shift info pointer dot x offset. Now that's fixed, but I think we should still be able to do the math with it. So what this will essentially do is, let's compare it to the other function real quick. Does it cast this at all? No, it just adds it. So I'm going to cast this to an int, because if we're going to randomize it and stuff, I think we should do an int. And then we'll set random x, rand y, and sample those. And then I'm going to show you that lastly, it's super easy to then change your other float functions to other bits per channel, because they're all using the same thing, just a different suite name and a different method name, you know, using 8, 16, or float in the name. So once again, we'll go ahead and apply this. And I've also discussed this quick tip a couple of times. You can see the last plugin I used wasn't the one that I was just testing. In order to do that, you need to close After Effects instead of closing it from Visual Studio. So if I apply Shifter, we're first going to see our effect, and we can't forget. The hardest part is not forgetting to close it from After Effects. But now you can see this just kind of creates like a dark effect, but you can see there's kind of just scattered pixels around. What if we change our offset? A lower value should produce less stuff, but maybe if I crank it up to like that. Perhaps in this case, we're having a bit of an issue with different data types. Let's go ahead and set a breakpoint and we can maybe find out. Let's see here. Our incoming X offset is negative 4 million. Yeah, these values might need to be cast. Okay, here's what we're gonna do. We'll just go back to the standard way we were doing this, 1920 and 1080, and I think that'll be fine. The issue there we were basically having is that anything in a 2D point parameter inside of your UI, the values you see are not actually like say 100 and 100. They're actually in fixed format, so they come off really strange and you have to convert them properly. And since we're just trying to get the sampling done in this quick tutorial or quick example, we're just going to remove that, apply shifter, and now we should have a pretty intense randomization spread. You can see this is actually just like creating noise, so to speak. So there's not just one way to make noise as well. And then this is just another possible method you can use to make noise. And looking at our speed performance, slightly faster, but still topping out around 3 seconds. So lastly, now that we could say this is our perspective function now working, and we want to port it to the other bits per channel. I'm going to copy everything from our out pixel to our randomized X and Y values here. I'm going to scroll up to 16, replace this stuff. Now we need to replace a few variables because we don't have a 16-bit, or we have a 16-bit color, not a 32-bit. And we're also not using the sampling float suite as is here. We're going to be using the sampling 16 suite, is it called? And then it will be subpixel sample 16. Sampling 16 suite 1 is the name. So we should change the name to that. And you can see just by changing the name, everything now works perfect. Copy the stuff one more time, scroll up to our 8 bits, paste it, and going from 16 to 8 bits is super easy. You just change the number 16 to 8. And then of course, this is a 16 pixel. You can just have a PF pixel or a PF pixel 8 is the same thing. Suites is undefined in this case. Did I overwrite it? I must have overwritten it. Or my suites coming in from... Why don't we just copy the whole function? This needs to be changed back to 16. I'm just going to copy the whole thing because I think somehow we're missing some data here. So we'll change all the 16s to 8s, 8. Sampling suite 16.1. Yeah, it needs to be 8 as well. Sampling suite has no subpixel, sample 8. Why not? What's it called? Sampling 8 suite 1. And it's just subpixel sample. Okay, now let's go ahead and test this in our other bits per channel, and I think we'll call it good. Just to remind you that these functions should also work in Premiere Pro. You may have had some issues before, but if you cast everything correctly, everything should work fine in Premiere as well. So most of the After Effects code translates pretty well to Premiere, with some exceptions that are listed in the guide. But this one in particular is fine. And you may have remembered that I was supposed to close After Effects, and you can see I forgot. It's very easy to forget that as you're testing really quickly. You see a result and you're like, okay, I need to tweak that value. And instead of closing After Effects to open the effect easy next time, you forget. So 32 bits looks good. 8 bits also looks good. It looks exactly the same. We'll just change the frame to make sure that the effect is looking the same. And then 16 bits per channel as well also creates the same effect. So that's just kind of a basic overview of sampling for 16, 32, and 8 bits per channel. You can see there I closed After Effects so that next time when I open it, it's going to be much quicker instead of having to navigate through my effects to find what I want to apply. Now all I have to do, ideally I would have a project that I could click on to open up already to make this quick, but now all I have to do is Control-Shift-Alt-E to apply my last applied effect, and I can then get it done much quicker. But that's going to do it for this week's video, guys. I hope you enjoyed. If you did, hit the thumbs up button. Down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel. And down in the description, you can follow us on GitHub for coding updates, as well as Instagram for other live updates. If you're not already a member of our Discord server, make sure you come and join to get help with scripting, extensions, plugins, submit tutorial ideas, and much more. And if you'd like to help support us on YouTube and get cool perks, you can become a member, supporter, premium supporter, or VIP. Link for that is in the description down below, where you can also check out the links to Adobe Exchange, AE Scripts, and Gumroad to check out some other cool stuff that I make. Thanks again for watching, everyone. We'll see you next time.